Hello friends, most welcome to my YouTube channel Maths by Samit Deshmukh. So today we are starting question number 3 from exercise 1.2. In this question we have to examine whether the given statement pattern is tautology, contradiction or contingency. So when we can say that statement is tautology, if it is always true, means its truth value in the last column, means if we are finding truth value of this statement, and if it is always t, at that time we can say that it is tautology. If it is always false, at that time we can say that it is contradiction, and if it is neither tautology nor contradiction, at that time we can say that statement pattern is what? Contingency. And to check whether the given statements are tautology, contradiction or contingency, we have to construct the truth table of the given statement pattern. So let us try to solve the first example. Here we can observe that only two letters P and Q appears in this statement, means only two statements are under consideration. So four possibilities of truth values are there. So let us try to construct the truth table. First find out truth value of P and Q. So here in case of and at least one statement is false, result will be false. So here in the first possibility false is not there, here false, 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 means in remaining three cases we will get false here. Observe the next statement, Q or P. So these two statements we are connecting by which logical connective? OR. And what we have seen in case of OR, if at least one statement is true, OR will be true. So true, 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 and here we will get false. True, 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 false. Lastly, we are connecting these two statements by which logical connective? Implication. Means which two statement? 3. This statement or truth value of this statement lies in third column and truth value of second statement lies in fourth column. And these two statements we are connecting by which logical connective? Implication. And what we have seen in case of implication, if TF appears, at that time only implication is false. So here TF does not appear, so it is true. Here also first statement is false. If first statement is false, implication is always true, not necessary to check what is the truth value of second statement. So here we can observe that this statement is always true, and such statement are called as what? Tautology. Now let us try to solve the second example. In the second example also, how many letters are there? Two letters P and Q, means only two statements are under consideration, so we have to construct the truth value for four possibilities. So here first find out truth value of negation P. Negation P. So from the truth value of P we will get its negation. Negation of true is false, again negation of true is false, and negation of false will be what? True. Then find out truth value of P implies Q. We know that implication is false if TF appears. Here TF is not there, so here we will get true. Here TF appears, so it will be false. Here first statement is false, that's why we can say that implication is true. Now find out truth value of negation P or Q. Truth value of negation P and Q are known to us. We are connecting these two statements by which logical connective? OR. In case of OR, at least one statement is true, result will be true. So here we will get true, false, true, 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 false, true, true. Once the truth value of first and second statement is known to us, connect these two statements, means 4 and the statement 5 by which logical connective? If and only, means by double implication. And what condition we have to remember in case of double implication? Double implication is true if truth values are identical, otherwise it is false. See, in the first case both statements are true, means truth values are identical. Here also both are false, means result will be true, because if truth values are identical, at that time double implication is true. So in every case truth values are identical, that's why we can say that double implication is true. And since the truth value of this statement is always true, so we can say that this statement is tautology. Now observe the next example. In this case also only two letters appears in the statement, means only two statements are under consideration, so we have to construct the truth table for four possibilities. So here let us first find out the truth value of negation P and negation Q. So negation P and negation Q. From the truth value of P we will get its negation. Negation of true is what? False. Negation of true is false. Negation of false is true. Negation of false is true. Here find out truth value of negation Q from Q. So negation of true is false, negation of false is true, negation of true is false, and negation of false is true. Now connect these two statements, means negation P and negation Q, means we are connecting these two statements by which logical connective? AND. And in case of AND, at least one statement is false, AND will be false. False, 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 true. So false, 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 true. Now we are finding negation of this statement. Truth value of this statement lies in column number 5, and we are finding negation of this statement, means negation of 5. Now in case of negation, we know that negation of false is true, negation of false is true, negation of false is true, and negation of true is what? False. Lastly, let us connect this whole statement and Q by which logical connective? OR. This whole statement means what? 6. 6 or Q. So 6 or Q. These two statements we are connecting by which logical connective? OR. So in case of OR, at least one statement is true, result will be true. So here true, true, true is there, and here what result we are observing? In the last case both are false, means what result we are getting? True, 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 and lastly false. So here we can observe that this statement is neither tautology nor contradiction, means all are not true and all are not false. Such statement is called as what? Contingency. So therefore given statement pattern is contingency. Now let us see the next example. In this case also two letter appears P and Q, means only two statements are under consideration. So here we will get 4 different possibilities of truth values. Now to find out truth value of this statement, first we have to find out P implies Q. In case of implication, we know that T of appears at that time implication is true. Sorry, implication is false, otherwise true. So here T of is not there, so true. T of appears, so it is false. So T of does not appear, so true. T of does not appear, so true. T of means first statement is true and second statement is false. Now this P implies Q means its truth value lies in column number 3, and Q we are connecting by which logical connective? AND. So means this statement and this statement we are connecting by AND, and in case of AND at least one statement is false, AND will be false. So here false is not there, so true. Here false is there, so AND will be false. Here we will get true and here we will get false. Lastly, connect these two statements by implication. So truth value of this statement lies in column number 4, which implies to what? P. Which implies to P. Means this is first statement, this is second statement, and we know that implication is false if T of is there, means first statement is true and second statement is false. So here T of does not appears, so true. We know that if first statement is false, so implication is always true. Here T of appears, so implication is false. Here if first statement is true, at that time implication is, if first statement is false, at that time implication is always true, not necessary to check what will be the second truth value of second statement. Here this statement is neither tautology nor contradiction, so we can say that this statement is what? Contingency. Now observe the next example. In the next example also, how many letter appears? 2 letter, P and Q. That's why we have to construct its truth table for these 4 different possibilities. Here to construct its truth table, we will require negation P also, and we will require negation Q also. Let us try to find out negation of P. Negation of true is false, negation of true is false, negation of false is true, negation of false is true. Now find out negation of Q. Negation of true is what? False. Negation of false is true. Negation of true is false. Negation of false is true. Isn't it? Now we are finding P implies Q. First we are finding what? P implies Q. Now P implies Q. These two statements we are connecting by implication. So if T of appears, implication is false. So here both are true, so result will be true. In the second case T of appears, so implication is false. Here first statement is false, at that time we can say that implication is true. Now let us connect this statement which lies in which column? 5U. 5U and negation Q by which logical connective? AND. So 5U we are connecting by AND with negation Q. So now observe the truth value of 5 and negation q appears in column number 4. These two statements we are connecting by and in case of and at least one statement is false, result will be false. So false, 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 true, false, 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 true. Lastly, this whole statement whose truth value lies in column number 6 is connected with negation p by implication. So these are the truth value of negation p. This is first statement, this is second statement, and we know that implication is false if tf appears. Here first three statements are false, so we can conclude that implication is true. In the last case also tt means tf is not there, that's why we can say that here also we are getting true, and since the truth value is true means this statement is always true, so we can say that it is what? Tautology. Now see the example number 6. In this example also two letters are there, means we can say that two statements are under consideration, and if two statements are under consideration, at that time we know that four possibilities of truth values are there which are already written here. So first we will require the truth value of negation q also, so find out negation q. So negation of true is false, negation of false is true, negation of true is false, negation of false is true. Now find out p if and only if q. So these two statements we are connecting by what? Double implication. In case of double implication, truth values are identical, double implication is true. So tt means t. Truth values are not identical, so false. Here also ft means truth values are not identical, so false. ff means truth values are identical, so true. Now p implies negation q. Truth value of p is also known, negation q is also known. Let us connect them by implication, means if tf appears, implication will be false. tf, so implication is false. True, true means implication is true. If here first statement is false, so we can say that implication is true. Now this statement which lies in column number 4 and column number 5 we are connecting by what? And means here column number 4 and column number 5 we are connecting by what? And. Observe these two statements. In case of and, at least one statement is false and will be false. So here we will get false, 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 lastly true. False, false, false and true. So here we can observe that this statement is neither tautology nor contradiction. So we can say that this statement is contingency. Now observe the next example. In this case also two letters are there, means two statements are under consideration, so four possibilities of truth values are there. So first find out negation of q. So negation of true is false, negation of false is true, negation of true is false, negation of false is what? True. Now we are connecting this negation p and negation q and p by which logical connective? And, means we are finding truth value of negation q and p. So truth value of negation q and p is known to us. Since we are connecting them by and, so in case of and, if one statement is false, and will be false. So false, true, false, 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 true, false, false. Now find out negation of this statement. Truth value of this statement lies in column number 4 and we are finding its negation. So negation of false is true, negation of true is false, negation of false is true, negation of false is true. Lastly, this column means fifth column. This whole statement lies in which column? Fifth column. And q we are connecting by what? And in case of and, at least one statement is false and will be false. So observe here we are getting true, then what? False, then what? True, and lastly here which false is there, so false. So here we can observe that these truth values, by observing these truth values we can conclude that it is neither tautology nor contradiction, means it is contingency. Now see the example number 8. In this example also two letter p and q appears, so here we are getting four possibilities of truth value. So first we are finding negation of q here. Negation of q. Negation of true is false, negation of false is true, negation of true is false, negation of false is what? True. Now we are finding truth value of p and negation q. So truth value of p and truth value of negation q are here. So we are connecting them by and. In case of and, at least one statement is false and will be false. So here we are getting false. So first statement is false. Here false is not there, so true, false, false. At least one statement is false and will be false. Now find out truth value of P implies Q. We know that implication is false if TF appears, otherwise it is true. So here TF does not appear, so it is true. TF appears, so it is false. So if first statement is false, implication is always what? True. In this way, truth value of both the statements are known to us. Truth value of this statement lies in column number 4 and truth value of this statement lies in column number 5, and we have to connect these two statements by what? Double implication. So what condition is there in case of double implication? If truth values are identical, double implication is true, otherwise false. So here truth values are not identical, so it is false. Here truth values are not identical, so it is false. Here also not identical, and here also not identical. So here simply we can observe that this statement is always false, and such statement is called as what? Contradiction. So given statement pattern is contradiction. Now let us try to solve the example number 9th. In this case, P, Q, R means 3 statements are under consideration. So we are getting total 8 different possibilities of truth values. So let us try to construct the truth table of this given statement pattern. So first let us try to find out negation of P. So these are truth values of P. We are finding their negation. Negation of this true will be false. So false, 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 and negation of false will be what? True. So here we are getting true. Now we are connecting negation P and Q by which logical connective? Double implication. So these are the truth value of negation P, and these are the truth values of Q. We are connecting these two statements by implication. In case of implication, if first statement is true and second is false, implication is false. Means just simply you have to check that TF appears or not. Here first statement is false in the first 4 cases, and we know that if in case of implication, if first statement is false, implication is always true. Now observe here, TF does not appear, so it is true. Here also TF does not appear, so it is true. Here TF appears, so it is false. Here also TF appears, so it is false. Once the truth value of first part is known to us, then find out truth value of P and R. So observe, these are truth value of P and these are truth value of R. In case of AND, if at least one statement is false, AND will be false. So here both are true, so result will be true. Here we are getting one false, so result is false. Here both are true, so result is true. Here false, 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 false. Means in remaining cases, at least one statement is false. That's why we can say that truth value of AND will be false. Lastly, we have to connect these two statements by AND. Truth value of this statement lies in column number 5 and truth value of this statement lies in column number 6, and we are connecting these two statements by which logical connective? AND. Let us see what result we will get here. In case of AND, if at least one statement is false, AND will be false. So here we are getting true, false, true, false, 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 false. Means at least one statement is false, truth value of AND will be what? False. So here easily we can observe that this statement is neither tautology nor contradiction, so we can say that this is what? Contingency. Now observe the last example from this exercise. So in this given statement pattern P, Q, R, 3 letters are there, so we have to construct the truth table for 8 different possibilities. So well, to construct the truth table, so first we will require the value of what? Negation Q. So let us try to find out negation of Q. These are truth values of Q. We are finding their negation. Negation of true is false. Here also we will get false. Negation of this false will be true. Negation of true is false, and negation of this false is true. Now find out truth value of negation Q or R. So truth value of negation Q and R are known to us. We are connecting these two statements by OR, and in case of OR, at least one statement is true or will be true. So here one T is there, so true. Here true does not appear, so false. Here T, T, T. So at least one statement is true or will be true. Here false, true, true. Now find out P implies this statement, and truth value of this statement lies in column number 5. So means this whole statement, truth value of this whole statement now lies in which column? Column number 6. So P implies 5. In case of implication TF appears, at that time implication is what? False. So here TF does not appear, so true. Here TF appears, so false. Here TF does not appear, so true. Here also TF does not appear, so true. And here first statement is false. At that time implication is always what? True. Whatever may be the truth value of second part. Now let us try to find out truth value of this second part of this statement. So here first let us try to find out Q implies R. Q implies R. So here we have truth value of Q and R. We are connecting them by implication. In case of implication TF appears, at that time implication is false. So here TF is not there, so true. TF means false. If first statement is false, means implication is always true. Here TT means true. TF means false. Again here first statement is false, that's why implication is true. Now again we are connecting P by implication with which statement? Q implies R. So these are the values of truth values of Q implies R, and these are the truth values of P. We are connecting these two statements by implication, and we know that in case of implication, statement or implication is false if TF appears. See, in the first case TF does not appear, so it is true. In the second case TF appears, so it is false. In the third case TF does not appear, so true. In the fourth case also it is true because TF is not there. And in the remaining four cases, if first statement is false, means we can say that implication is always what? True. Now truth value of this part is known to us, which lies in column number 8. We are finding negation of it, means negation of 8, and the truth value of this whole statement now lies in which column? 9. Let us try to find out negation of this 8. Negation of true is false, negation of false is true, negation of all these true will be false. Negation of true is what? False. Lastly, let us connect these two statements 6 and 9. Truth value of this statement lies in column number 6 and this statement in column number 9, and we have to connect these two statements by double implication, means 6 double implication 9. Okay, so now let us try to construct its truth table, means observe the truth value of 6 and 9. In case of double implication is true if truth values are identical, and if not identical then double implication is what? False. In the first case TF means truth values are not identical, so false. Here also not identical, so false. Here also not identical, false. Not identical, false. Not identical, false. Not identical, not identical, not identical, means in each case we are getting what? False. And observing the truth value of the given statement, we can say that it is contradiction because it is always false. So given statement pattern is what? Contradiction. In this way we have completed all the example from this exercise. In the next video we are starting next article from this chapter.